So next method, actually this is same as previous method. In the previous method, I mean inverse matrix inverse method. This is also similar one, but here we apply the elementary row operation method. Small variation. In the previous one, we find the inverse, our known method, but here we have four variables. 3 by 3, okay, finding inverse. 4 by 4, 5 by 5, it is very difficult to find inverse by the processor. So that's why it is better to avoid to solve this equation by the previous method. It is used by applying row operations, it is easy to solve the problem. So my suggestion is solve the problem. Here you remember that row operation, there are 3 row operations. Later we solve the problem because we need row operations. Similarly, we have column operations, row operations. Row operations. First row operation is we can interchange any two rows. Ith row into jth row into ith row. This is one of the first property. Second property, ith row is replaced with some scalar multiple of same row, where k is a non-zero number, non-zero value, where k not equal to 0. Same row is replaced with some scalar multiple of same row. Or ith row is replaced with k times of ith row. Previously we have 2. Suppose we multiply with k, we get 2k, 2k, 3k, like that. K value is some value, either 1 by 2 or minus 1 by 2, minus 0.5, like that. Next important property, ith row is replaced with ith row plus some scalar multiple of jth row. So here k may be 0 or same value. K may be any value, either 0 or non-zero value in the third property. The second property only k not equal to 0. In the third property, k may be 0 or may not be 0. These three properties, we apply these three properties, solve the above system of equation. First, find the inverse. Sometimes in the examination point of view, we may ask find the inverse of the coefficient matrix. In place of solving the equation, find the inverse of the coefficient matrix. First, write down the coefficient matrix in the above equation. Answer. Coefficient matrix A equal to, what are the coefficients? 1, minus 1, 1, 1, 1, 1, minus 1, 1, 1, 1, 1, minus 1, 1, 1, 1, 1. So 1, minus 1, 1, 1. Next row 1, 1, minus 1, 1. Next row 1, 1, 1, minus 1. Next row all are positive. This is A. Find A inverse. First find A inverse by using row operations. Find A inverse using elementary row operations. In examination point of view also like that. Find A inverse, not R inverse, using row operations. You must remember this method. In the examination point of view, we may ask up to A inverse only. So in this process, first step is take A and identity matrix of same orders. A is a 4 by 4. You take I is also a 4 by 4 matrix. A value is 1, minus 1, 1, 1, 1, 1, minus 1. A matrix value is this. So dot means after that you write down identity matrix value 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. If you have any confusion, write down dot lines. Now apply the row operations, convert A into I. Then the right hand side part should be a inverse value. So by using row operations, convert the A portion into identity matrix. So in B portion, we get some other matrix. That matrix, nothing but A inverse. So we convert identity matrix. That means first row, first element 1, remaining 0. Diagonal element 1, above and below 0. So diagonal only 1. So 4 by 4 matrix, diagonal should be 1. Other values make into 0. So by using row operations. So row operations, R1 keep as it is because first element is 1. R2 should be R2 minus R1. After that we get 0. In the R3 minus R1. R4 tends to R4 minus R1 because they have positive sign. So now 1 minus 1, 1, 1, 1, 0, 0, 0. We can apply total row, 8 elements. First part is A, second part is identity. So here 0, R2 minus R1. Here R2 minus R1 plus 2, minus 2, 0, minus 1, 0 minus 1, 1 minus 0, 0 minus 0, 0 minus 0. This is R1 row, resultant R1 row. So resultant R3 row is 0, 2, 0, minus 2, 0 minus 1, minus 1, 0 minus 0, corresponding entry 0, plus 1, 0. The last row 0, plus 2, 0, 0. Now this value minus 1, 0, 0, plus 1. So next target is we make this 2 into 1, and below and above are zeros. So R2 tends to 1 by 2 times of R2. So keep first row as it is, 1, minus 1, 1, 1, 1, other 3 zeros. Second row becomes 0 by 2, means 0. 2 by 2, 1, minus 2 by 2, minus 1, 0 by 2, 0, minus 1 by 2, plus 1 by 2, 0, 0. Just here I apply the operation for the second row only, not other rows. As your wish, by the practice you can apply any manner, but our intention is find A inverse. As per procedure, A inverse get when we make the left hand side portion A into identity matrix. The right hand side portion should be the A inverse. Now make below and above zeros. Second diagonal element is this one. Make above and below or should be zeros. That means R1 tends to R1 plus R2, because in R1 plus we have minus 1, R2 plus 1. So R3 tends to R3 minus 2 R2. R4 tends to R4 minus 2 R2. It should be 1 minus 1, 1, 1, 1, 0, 0, 0. This should be 0. Oh, sorry. Here 0. R1 plus R2. 1 plus 0, 1. Minus 1 plus 1, 0. Here 0. Here 1. Here 1 minus 1 by 2 means 1 by 2. Here plus 1 by 2. 0, 0. Okay. Second row 0, 1, minus 1, 0, minus 1 by 2, 1 by 2, 0, 0. Now third row by using this operation R3 minus 2 R2. 0, 0. 0 minus 2 R2 means plus 2. Minus 2. Minus 1. Minus of minus plus. Minus 1 plus. If you have any confusion, write on side. Minus 1 by 2. 2 get cancelled. Minus into minus plus 0. 5 elements are over. 2, 4, minus 1. So next element 0 minus 1 by 2, minus 1. Next element 1 minus 2 into 0, 1, 0. The last row 0, 2 minus 2 0, 0 0 minus 2 plus 2, 0 minus of minus 2 0, minus 1 minus of 2 times of minus 1 means 0, 0 minus 2 into 1 by 2 means minus 1, 0 1, which is equal to next diagonal element make into 1. So it is better to make first here 1. Somewhere I made a mistake because here we get 1 immediately. R1 minus R1 0. Okay, one more time I will verify the question. Okay, anyhow, no problem. Later we can interchange the rows. So because it is better to interchange here, third row we have only one element. So here only it is better to interchange R3 into R4, R4 into R3. 1 0 0 1 1 by 2 1 by 2 0 0 0 1 minus 1 0 minus 1 by 2 1 by 2 0 0. So third row converted into fourth row converted into third row. That's all. Now make this 2 into 1 because in the identity matrix we should have 0 in the right hand side. That's why I make the interchange of the rows. R3 tends to R3 by 2 because in now current R3 row is this one. Other rows as is. I don't want to explain too much because this method is applicable to find inverse of A first of all. Later apply A inverse into B, we get X value. Fourth row, no change. Now, so we want to make diagonal, next diagonal element 1. Here 0, here 0. So that means R2 tends to R2 plus R3 row. R4 tends to R4 plus 2 R2 to R2. Plus or minus? Minus because here we have plus sign. Minus 2 R2. Not R2, R3. Because up to R2 over. Next row diagonal element is R3 row diagonal element. Here 0, 0. So R2 row, apply the R2 row operation. 1, here 0. 0 plus 0, 0. 1 minus 1 by 2, 0, 0. 1 by 2 plus 1 by 2 minus 1 by 2, 0. 0. Here last element is 1 by 2. Third row is 0, 0, 1, 0, 0. No change in the third row. 0, 1 by 2. The next row operation is 0, 0, 2 minus 2. 0 minus 2 minus 2 times of 0 minus 2. 0 minus 1 minus 2 times means 0. 1 0 minus 2 times means minus 1. Almost we reached. So here minus 2 is there. We want to make into 1 because the diagonal entry should be 1. It makes into identity matrix, but here 1 is there. First make this value into 1. Later we will think about above column element make into 1. R4 tends to R4 by 2. 1 0 0 1 1 by 2 1 by 2 0 0. Next row 0 1 0 0 minus 1 by 2 0 0 1 by 2. Next 0 0 1 0 0 minus 1 by 2 0 1 by 2. Fourth row reduces to 0 0 by applying minus 1 0 0 1 by 2. Oh, sorry. 0 0 triple 0. Then 1 0 0 1 by 2 minus 1 by 2. So now here diagonal element, you observe that this is the diagonal. Still now it is not identity matrix because here 1 is there in the first row. Using fourth row, make into 0 in the first row. That means R1 tends to R1 minus R4. Applying this operation, we get 1 minus 0, 1, 0 minus 0, 0, 0 minus 0, 1 minus 1, 0, 1 by 2 minus 0, 1 by 2, 1 by 2 minus 0, 1 by 2, 0 minus 1, 0 minus 1 by 2, minus 1 by 2, 0 minus of minus 1 by 2 plus 1 by 2. That's all. So 0, 1, other rows, no change. 0, 0, 1 by 2. Here 0, 0, 1, 0, 0, minus 1 by 2, 0, 1 by 2. Next row is 0, 0, 0, 1, 0, 0, 1 by 2, minus 1 by 2. That's all. We reached our goal. Here identity matrix. So this is equal to I into A inverse. So therefore A inverse part is, so without finding adjoint det, actually as per definition A inverse equal to adjoint A by det. Here we are not using the basic definition, just we apply the row operations. 1 by 2, 1 by 2, minus 1 by 2, 1 by 2, minus 1 by 2, 0, 0, 1 by 2, 0, minus 1 by 2, 0, 1 by 2. The last row 0, 0, 1 by 2, minus 1 by 2. This is A inverse. So now we want to find X. Thus, X equal to A inverse into B. Already we know the A inverse value. Already we know the B value. Multiply and equate these two matrices. We get the A inverse. Into B value. What is the B value? See. Right hand side bounds. 2 minus 4, 4, 0. 2 minus 4, 4, 0. 2 minus 4, 4, 0. Sometimes they may ask up to A inverse. Using elementary row operation, find A inverse. That time you apply the row operation, find A inverse up to A inverse only. So that implies row by column operation, 1 by 2 into 2 plus 1 by 2 into minus 4 minus 1 by 2 into 4 plus 1 by 2 into 0 first row. Second row minus 1 by 2 into 2, 0 into minus 4 plus 0 into 4 plus 1 by 2 into 0. Next element 0 into 2 minus 1 by 2 into minus 4 plus minus 1 by 2 into minus 4 plus 0 into 4 plus 1 by 2 into 0. Last element 0 into 2 plus 0 into minus 4 plus 1 by 2 into 4 plus minus 1 by 2 into 0. Simplify this expression, we get solution 1 minus 2 minus 2 0. First row element minus 1 0 0 0. So next row 0 minus 1 into minus plus plus 2 0 0. Last element 0 0 2. That implies minus 4 plus 1 means 3. Minus 3 minus 3 minus 1 2 2 be the solution. That is, the solution is equating the matrices. The solution is x equal to minus 3, y equal to minus 1, z equal to x, y, z. See in the problem what are the variable names they are given. x1, x2, x3, x4. So don't put x, y, z. x1 is minus 3, x2 minus 1, x3 plus 2, x4 plus 2. Now substitute these values in the system of equation. If we get LHS equal to RHS, our solution is right. Otherwise, our solution is wrong. Don't bother about the solution value because sometimes we get some errors in the process. But procedure is important. Minus 3 plus 1, minus 3 plus 1, minus 2, then 2 plus 2, 4, 4 minus 4 minus 2 equal to plus 2. So our solution is right. Substituting the values, we get LHS equal to RHS as the problem. This is the method. It is sometimes, most of the time, they may ask find A inverse by using elementary row operation, by giving 4 by 4 or 5 by 5 order matrices. 3 by 3, no issue. 4 by 4 and 5 by 5 only difficult task.